A few days before the new year, the scientific world was shaken by the remarkable discovery by Wilhelm Röntgen of a queer, unknown energy that he called X-rays, which emanated from his Lenard and Crookes tubes. Michael Pupin wrote, "No other discovery within my lifetime had ever aroused the interest of the world as did the discovery of the X-rays. Every physicist dropped his own problems and rushed headlong into the research." Astonishingly, Pupin added, "To the best of my knowledge, I.W. Rays at that time, the only physicist here who had had any laboratory experience with vacuum tube research. I obtained the first X-ray photograph in America on January 2, 1896, 2 weeks after the discovery was announced in Germany." As Pupin could so neatly do, he forswore any mention of his compatriot. To Pupin, Tesla was an in-person. Röntgen gained world recognition virtually overnight with his announcement that he had discovered a new energy emanating from cathode ray tubes that could illuminate light-sensitive chemicals at the far end of a room, penetrate solid objects, and photograph the internal organs and bones of living beings. As Pupin noted, scientists from all over the world dropped their current projects to join in this exciting new venture. Tesla himself wrote no fewer than 9 articles on the topic in a 2-year period. Although Tesla may have noticed these rays and their effects on photographic paper years earlier, he did not pursue the investigations and left no doubt that the discoverer of what he liked to call shadowgraphs was Wilhelm Röntgen. Tesla had taken the word shadowgraph from Søren Kierkegaard, who described them in his essay, Either Or. To the existential philosopher, they were sketches that derive from the darker side of life, but are not directly visible. The shadowgraph does not become perceptible until I see through the external, not until look through it. Do I discover that in a picture too delicately drawn to be outwardly visible, woven as it is of the tenderest moods of the soul. In Europe, meager X-rays were being produced by static machines and Rumkopf induction coils. Tesla suggested, instead, the use of a high-frequency disruptive coil attached to a special bulb with 2 electrodes, a cathode inside the vacuum for generating the cathode streams, and an anode placed as far away as possible outside the bulb to limit the reduction of the potential. With this apparatus, effective pressures of about 4,000 volts were achieved. At first, the bulb will get hot and glow with apoplectic hue. Then the electrode will disintegrate, and the bulb will cool. Use of a fan helps. From this point on, the bulb is in a very good condition for producing the Röntgen shadows. When the electrode is too hot, it is probably because the vacuum is not high enough, generating such high voltages. This work not only was set up to measure the quality of the energy emanating from the bulb, and to test its ability to pierce living and non-living objects or be reflected, it also laid the foundation for Tesla's later experiments with particle beam weapons. Here, in 1896, Tesla discussed the idea promulgated by the quantum physicists a few years later that the energy had both particle-like and wave-like properties. Having set up a target to shoot the streams at, Tesla wrote, "The effects on the sensitive plate are due to projected particles or else to vibrations of extremely high frequencies." The inventor further speculated that the streams are formed of matter in some primary or elementary condition. Similar streams must be emitted by the sun, and probably by other sources of radiant energy. Tesla also appeared to have come close to the idea of breaking up the electron into subatomic particles. The projected lumps of matter act as inelastic bodies, similarly to ever so many small lead bullets. These lumps are shattered into fragments so small as to make them lose entirely some physical properties possessed before the impact. Might it not be possible that in the Röntgen phenomena we may witness a transformation of ordinary matter into ether? Or we may be confronted with a dissolution of matter into some now primary form, the AKSA of the old Vedas. The inventor as physicist then proceeded to take X-rays of smaller animals, such as birds and rabbits, as well as his workers, and of his own skull, ribs, limbs, and vertebrae. As some shadowgraphs took as long as an hour to obtain, Tesla noticed that he would sometimes fall asleep while he was being bombarded by the machine. Week after week, Tesla would crank out yet another article on his latest results. On March 181,896, he announced in Electrically that he had produced shadowgraphs of humans at distances of 40 feet and affected photosensitive paper at a distance of 60 feet from the source of the rays. The inventor also tested different metals to see which ones reflected the energy in the best way. Adorned with a lavish X-ray of the bones of the wizard's own rib cage, the article conveyed an eerie impression. I told some friends, Tesla wrote, that it might be possible to observe by the aid of a screen objects and skeletons passing through a street. I mention this odd idea only as an illustration of how these scientific developments may even affect our morals and customs. Perhaps we shall shortly get used to this state of things. For Tesla, Röntgen rays were a gateway to a world invisible and ripe for new possibilities. Röntgen gave us a wonderful gun to fire projecting missiles of a thousandfold greater penetrative power than that of a cannonball, and carrying them probably to distances of many miles. These missiles are so small that we may fire them through our tissues for days, weeks, and years, apparently without hurtful consequence. Throughout the year, the inventor suffered from the grip. Although his illness made the papers, nobody seemed to link it to his excessive experimentation with the mysterious energy. In fact, concerning the risk to one's health, Tesla wrote, no experimenter need be deterred from investigation of Röntgen rays for fear of poisonous or generally deleterious action, for it seems reasonable to conclude that it would take centuries to accumulate enough of such matter to interfere seriously with the process of life of a person. We now know, of course, that this view is wrong, as long-term exposure to X-rays can be very dangerous to one's health. Tesla did, however, refer to pain in the center of his forehead when experimenting with the rays and to the hurtful action on the skin, inflammation and blistering, but this he attributed to the production of ozone, which in small quantities was a most beneficial disinfectant. Nevertheless, there was a severe accident in the lab to a dear and zealous assistant without a protective screen present. The worker suffered severe blistering and raw flesh exposed, the inventor undertaking the bitter duty of recording the accident in order to lessen the danger for others. Edison was also making headlines with his work with Röntgen rays, especially when he noted that the streams caused blind people to experience sensations in their eyes. The X-rays succeeded in eliciting from the blind the ejaculation, "I see, yes, I see a light." Edison, whose fluoroscope was already being used for lighting the eye during eye surgery, saw the possibility that eyesight, in some way, might be restored with the use of X-rays. Tesla doubted it, and so the press took up the charge and created a new round of headlines placing the two pioneers once again against each other. The humorless dark Hungarian had the unpleasant duty to say, "Is it not cruel to raise such hopes when there is so little ground for it? What possible good can result?" Time proved Edison wrong, as X-rays have not been used to stimulate the retina in such a way as to restore sight. But the two wizards did perform a number of successful miracles with the strange energy when each used the instruments to locate bullets lodged in the bones of various patients. Fortunately, the Kentucky School of Medicine helped bring the battle between the two to a close when they combined the devices of Tesla and Edison to extract birdshot from the wounded foot of a voter who had received the injury in a fight at an election poll. After developing the X-ray, which took only 90 seconds to make, every bone was distinctly shown, and the short, about 30 in number, were plainly located. To celebrate the triumph and quell any purported hostilities, T.C. Martin was able to coax Tesla into joining Edison and a number of other electricians for a day of fishing on a topsail schooner of Sandy Hook. The event was sponsored by the Safety Insulated Wire and Cable Company. Although a storm erupted, accompanied by dark clouds and lightning, the bold fishermen were undismayed. In stately grandness, as happy and well satisfied a party as ever rode the waves of the Atlantic's BIL lows. Toward nightfall, the ship turned her prow homeward. Nikola Tesla caught a flounder of large dimensions, and Edison caught a shocking big fluke.